Welcome to Mastering JavaScript Unit Testing. In this comprehensive 4-hour course, I will take you on an exciting journey where we will explore everything you need to know about unit testing, from the very basics to more advanced techniques. If you're looking for a comprehensive, easy to follow, well-organized, and practical course that takes you from zero to hero, this is the right JavaScript unit testing course for you. This course is packed with real-world examples and a ton of hands-on exercises, giving you plenty of opportunities to practice what you learn. By the end of this course, you'll have a strong foundation in unit testing. You'll be able to significantly reduce bugs and improve the overall quality of your code. This expertise will set you apart in the world of software development, opening doors to exciting opportunities and challenges. So if you're ready to unlock the full potential of JavaScript unit testing and elevate your coding skills, join me in this exciting journey. I'm Mosh, a software engineer with over 20 years of experience, and I've taught millions how to code and become professional software engineers through my YouTube channel and online school, codewithmosh.com. If you're new here, make sure to subscribe as I upload new videos all the time. Now, let's jump in and get started. Now, to take this course, you don't need any familiarity with unit testing at all. In fact, I've designed this course specifically for people who have never done unit testing because they find the idea intimidating. So I'm going to teach you everything from the ground up. But to take this course, you should have a basic understanding of modern JavaScript. That means you should be comfortable with concepts like importing and exporting, promises, async and await, and so on. If you need to brush up on any of these concepts, check out the JavaScript series on my website. So that's all about the prerequisites. Next, we're going to talk about the course structure. All right, now let's talk about how I've structured this course. This course serves as the rock-solid foundation for unit testing in JavaScript applications. However, I want to clarify something up front. We won't be testing a front-end or a back-end here because our primary focus is on nailing those fundamental unit testing concepts and best practices that often get overlooked in many other courses. This is where a lot of folks stumble when it comes to unit testing. They rush into testing React or Node without grasping the essential foundations and best practices. So in this course, my goal is to equip you with a robust foundation. Once you have completed this course, you'll be well prepared to tackle my other courses on testing React or Node. Now here's our roadmap for this course. We'll kick things off by getting you familiar with the basics of unit testing. So in the first section, we'll cover what unit testing is, what are its benefits, and what are the common arguments against it. Then we'll see unit testing in action. You will learn how to write basic tests and run them. Next up, we'll delve deeper into core unit testing techniques and best practices. We'll cover concepts like positive and negative testing, boundary testing, parameterized testing, and so on. Then we'll explore how to use mocks or fakes to isolate our code during tests. This is a very important technique used in unit testing. In the final section, we'll explore some handy static analysis tools like ESLint, Prettier, and TypeScript. These tools help you elevate the quality of your code and reduce the need for extensive test cases. Once you finish this course, you'll have a rock-solid foundation for testing JavaScript code. If your goal is to write JavaScript libraries, you can take what you learn in this course and use it to test your libraries. If you're a front-end developer and want to learn how to test React applications, I've got you covered. I'm planning to create a dedicated course on the topic, and chances are, by the time you're watching this course, my React testing course is already published. As for backend testing, I've covered it in my Node course, so at this point, I'm not planning to create a separate course on the topic. All right, now let's talk about how to make the most of this course. If you're brand new to unit testing, the best approach is to follow the lessons in order and complete the exercises along the way. It'll help you build a strong foundation. However, if you already have some experience, you might be tempted to jump around and focus on specific lessons. While that's an option, because the course is well structured, I would like to advise you against it. Why? Well, you might unknowingly have some bad habits or be using less than optimal practices. As your instructor, I strongly recommend going through all the lessons sequentially. The fantastic part is that the course is concise and to the point, so you can easily complete it in a single day. Plus, it's full of practical examples and exercises, so you're not going to get bored with fluff content. All right, now that we're on the same page, our next step is setting up our testing environment. All right, let's talk about setting up our testing environment. First, head over to nodejs.org and download the latest version of Node. Now, in this course, just like my other courses, I'll be using Visual Studio Code or VS Code as my editor. You're welcome to use your preferred editor, but in this course, I'm going to show you a ton of shortcuts for increasing your productivity. So, while not necessary, I recommend you to download and install Visual Studio Code. All right, before we move on to the next section, I want you to download the starter project I have created for this course. So head over to github.com/mosh-hamedani. Here, go to repositories and search for JavaScript-testing. Here we have two repositories, the starter project and the finished project. The finished project contains the solution to all the exercises I have created for you. So let's start with the starter project. Then go to code, clone this URL. Next, open a terminal window and run git clone followed by the URL. All right, good. So here we have this folder, JavaScript testing starter. Just open this with VS Code and you're good to go. Welcome back to another section of Unit Testing JavaScript course. This section is going to be your gateway to the world of unit testing. We'll kick things off by talking about what is unit testing, what are its benefits, and what are common arguments against it. Then we'll talk about different types of tests we encounter in real-world applications. Once we've got the theory covered, we'll talk about the tooling. We'll explore various testing frameworks out there. In this course, we'll be using Vitest, which is a relatively new testing framework that has gained popularity. But the concepts you will learn in this course apply to other testing frameworks like Jest as well. So next, we'll set up Vitest and write our first unit tests. You'll see unit testing and its benefits in action. Then I will introduce you to the concept of test-driven development or TDD. We'll talk about the benefits as well as a few misconceptions about TDD. Next, I will show you various ways to run your tests efficiently. This is a key skill you need to have, especially when you deal with broken tests. You should be able to quickly filter your tests and focus on one or a few at a time. Now, every seasoned developer is expected to know how to navigate their code base quickly and smoothly. So I will show you various shortcuts in VS Code to navigate your tests and production code. Last but not least, we'll wrap up this section by talking about code coverage, which is a metric that shows how much of our code is tested. This is a great introduction to unit testing, so let's jump in and get started. So what exactly is unit testing? Well, unit testing is a form of automated testing where we write code to check if our code works as expected. Here's an example. Imagine we have a function for calculating the monthly loan payment. Now, if we were to test this function manually, we would have to launch our application, possibly log in, navigate to a particular page, fill out a form, submit it, and then check if the result is calculated correctly. As you can see, this is pretty time-consuming. This is where automated testing comes to the rescue. We can write some code to directly call this function with various inputs and check if it returns the correct result. We execute this code using a program called a test runner, which displays test results in the console or terminal window. If a test passes, we see a green tick, otherwise we see a red cross. Using this technique, we can run hundreds or even thousands of tests in just a few seconds. Clearly, this is much faster than manual testing through the user interface. With automated testing, our code base consists of two types of code: the application code, also known as production code, and the test code or tests. Once we have a suite of tests, we can run them every time we make changes to our code. And this brings us a bunch of benefits. Firstly, unit tests help us identify and fix bugs early in the development process, long before they become nasty surprises in production. There have been many studies that show that the later we find and fix a bug in the development process, the costlier it is for the business. For example, fixing a bug after deploying the software can be up to 5 times more expensive than during the coding phase. Secondly, unit testing helps us refactor our code with confidence. Refactoring means changing the structure of our code without changing its behavior or functionality. For instance, we can extract a few lines of code and put them into a separate function. We're changing the structure of the code, but not its functionality. With unit tests, every time we refactor our code, we can run our tests to quickly confirm if our code still behaves as expected. Thirdly, writing unit tests encourages us to consider various edge cases and error conditions, and this leads to more robust and reliable code. And lastly, unit tests serve as documentation for how our functions should behave, and this makes it easier for others to understand and maintain a project. Now, despite these benefits, we have developers with very strong opinions, like our famous superstar developer, Mr. John Smith, who's skeptical about unit testing. He proudly claims that in his 20 years of software engineering, he's been writing bug-free code without ever writing a single unit test. On the other side of the spectrum, we have other developers like Test Smith who are obsessed with writing tests and say every line of your code should be covered by tests. So who's right? Well, in my opinion, both of these viewpoints are extreme and can be costly for a business. Having no unit tests at all and relying solely on manual testing can be very time-consuming, especially as our application grows in size and complexity. On the other hand, covering every line of code with tests can also be very expensive. We always have time and resource constraints. So next time you encounter one of these folks with strong opinions, don't get caught up in their debate. Instead, be pragmatic and find a good balance that works for your project. Keep in mind that every project is unique. New projects with rapidly evolving requirements might not be the best candidate for extensive unit testing, because as the requirements change, some of your tests may break and you end up spending more time fixing broken tests than delivering actual features. However, if your project is more established and certain features have stable requirements, it's a good idea to write a suite of tests to ensure that at least the critical modules continue to work as expected. This way, whenever you make changes to those modules, you can run your tests to get immediate feedback if you have broken something or not. In reality, unit testing is an investment in software quality. Like any investment, it can be fruitful or go wrong. If you skip writing tests entirely, you will rely solely on manual testing, and this will get increasingly costly over time. On the other hand, writing poor tests that produce inaccurate results and fail to give you real feedback about your code's reliability is a waste of time. So, just like how you should wisely invest your money, you should also use your time wisely when writing tests. You should write good tests that are maintainable, robust, and trustworthy. And that's what I'm going to teach you in this course. If your tests are not maintainable, robust, and trustworthy, they offer no value. They get in the way and slow you down. It's better not to write them at all. All right, next, we're going to talk about different types of tests. In automated testing, we have 3 types of tests: unit tests, integration tests, and end-to-end tests. So what are the differences? Well, unit tests verify the correctness of individual units or components of an application in isolation. These units could be functions, classes, or even small modules. These tests are incredibly useful for catching bugs early in the development process. Integration tests focus on verifying how different units or components of your application work together as a whole. They help you identify issues that might arise when combining different units, such as data flow problems, communication between modules, and compatibility issues between components. End-to-end tests are the broadest type of tests, focusing on testing the entire application as a whole. They simulate real user interactions with the entire system, from the user interface down to the backend services. They're excellent for ensuring that our entire application works seamlessly from the user's perspective. Now, a common question that I get is, what types of tests should we write? Well, the classic recommendation is to have more unit tests than integration tests, and more integration tests than end-to-end tests. This is referred to as the testing pyramid. However, this is just a suggestion. It doesn't mean you should follow it religiously because every application is different. In some cases, it may make more sense to have more integration tests or more end-to-end tests. There is no one-size-fits-all in software engineering. Anyone who tells you there is only one way to do something and that's the best way, they're either selling you something or they haven't been around long enough. So when designing a testing strategy for your application, consider the complexity of your application's code, as well as your time and resources to come up with a suite of tests that give you the most value. But there is one thing crucial you need to understand about the testing pyramid. As we go up this pyramid, in other words, as we test more units of our code together, our tests will be slower, but they will give us more confidence in the reliability of our application. So end-to-end tests give us the highest confidence, but they're significantly slower. Running them every time we change or refactor our code isn't always feasible. This is where unit tests come into play. Unit tests are incredibly fast, so we can run them every time we change or refactor our code to get immediate feedback if we have broken something. So, all these types of tests are valuable. It's hard to determine which type has more value. It's like debating what type of shoes is more valuable, dress shoes or running shoes. Well, it depends where you want to go. So don't listen to folks with strong opinions on social media saying things like unit tests are a waste of time and they only write end-to-end tests. Well, good for them. Anyway, in this course, our focus is entirely on unit testing, so you don't need to worry about integration and end-to-end tests at this point. In the second part of this series, where we will look at testing React applications, we'll talk about integration tests. So I mentioned earlier that we need a test runner to execute our tests. Now, this is where testing frameworks come into the picture. A testing framework is a set of tools for writing and running tests. It typically includes a test runner for executing tests, assertion libraries to check if the code behaves as expected, mocking tools to replace certain modules with fakes simulating different scenarios, test coverage tools for measuring how much of the code is tested, and many other tools. Now, there are several testing frameworks out there like Jest, Mocha, Jasmine, Vitest, Cypress, Playwright, and many, many more. All these frameworks work more or less the same way. So once you get the hang of one, you can easily pick up other frameworks. Among these, Jest is the most widely adopted and used in many projects. However, there is a little catch with Jest. It's an older framework, and its support for ECMAScript modules or native JavaScript modules is still experimental. So setting up things can be a little bit awkward. So in this course, we're going to take a different route. We'll be using Vitest, which is a new testing framework designed for modern JavaScript. It has all the fantastic features of Jest, as well as out-of-the-box support for ECMAScript modules, TypeScript, and JSX, which is used in React. Plus, its API is almost identical to Jest. So everything you learn about Vitest in this course will be directly applicable to Jest as well. All right, now we're ready to set up Vitest. So I have opened our starter project in VS Code. Now we need to open a terminal window to install Vitest. So on the top, under the View menu, let's go to Terminal. Look at the shortcut. It's Control and backtick. So here we're going to use npm to install Vitest as a development dependency because we don't want to deploy our test tools with our application, so we always install them as development dependencies. So let's install Vitest. Lovely. Now we need to go to our package.json file and create a test script. So here in the scripts object, we add a new key value pair called test and set it to Vitest. Now, whenever we run npm test, Vitest will execute our tests. So if you go back to the terminal and run npm test or npm t, Vitest will execute our tests. Now, currently we don't have any test files. That is why we get this error. In the next lesson, we're going to create our first test. All right, we're going to write our first test. So here in the source folder, we have a module called intro. In this module, we have all the code we're going to use in this section. So here we have a function for getting the max of two numbers. Pretty basic. If A is greater than B, it returns A. Otherwise, if B is greater, it returns B. Otherwise, if they're equal, it returns A. I know this is not the best way to write this function. This is deliberate. Once we cover this function with tests, we'll come back and refactor it into a more elegant implementation. So to test this, we're going to go in the root of our project. Next to the source folder, we create a new folder called tests. And here we create a test file for the intro module. So we call it intro.test.js. This is the pattern that Vitest or Jest looks for. So Vitest by default picks up files that have test in their name. And of course, this can be configured, okay? Now, in this file, we're going to import a few functions from Vitest. One of them is describe for creating a test suite or a group of related tests. The other one is test for creating a test case. There is also another function that does the same job. It's called it. We'll talk about it momentarily. And one more function that is expect. So first we call the describe function to create a test suite or a group of related tests. We give it two arguments. The first argument is a string that is the name of our test suite. Typically, we use the name of the function or the unit under test. In this case, max. The second argument is a function that will be called by our test runner. In this case, Vitest. So here we pass an arrow function. Now, in this block or in this test suite, we define one or more test cases. So we call test or it. It doesn't matter. It's a matter of personal preference. Now, just like the describe function, here we need two arguments. The first argument is a string that represents our test name. So look, here we want to test a scenario where A is greater than B. So to name this test, here we can pass a string like should return the first argument if it is greater. Now look, the reason some people prefer to use the it function is because the test case reads like it should return the first argument if it's greater. Very clear. So always pay great attention to naming your tests. I have seen some people naming their tests like test 1, test 2. Don't do that because over time, it's not going to be clear what is the purpose of these tests. So always treat your tests as first-class citizens. Your test code is as important as your production or application code, okay? So here's a test name. Now the second argument should be a function that will be executed by our test runner, in this case, Vitest. Once again, we pass an arrow function. Now, in this test, we typically structure our test using the AAA pattern. That is short for arrange, act, and assert. This is a pattern that a lot of people follow when organizing their tests. In the arrange phase, we set up our test environment, including any necessary data or configurations. In the act phase, we perform the action we want to test. And in the assert phase, we check the outcome to ensure that it matches our expectations. Let me give you a real example. Imagine we want to test that a TV can be turned off. In the arrange part, first we turn on the TV. In the act part, we press the power button. And in the assert part, we verify that the TV is off. Okay? Now we can take this analogy and apply it to our tests. So in the arrange part, first we declare two variables or two constants. We can call them A and B. We set A to 2 and B to 1. Now these are arbitrary values. We could use 20 and 10. We could use 10 and 9. It doesn't matter. What matters is that we want the first argument to be greater. Now in the act phase, we perform the action we want to test. In this case, we call the max function that is defined in this module. So let's press enter. The max function is imported on the top. Now we pass our arguments A and B, get the result and store it here. Now finally in the assert phase, we verify that the result is correct. To do that, first we call the expect function of Vitest. And by the way, Jest has the same functions and they work exactly the same way. So we call expect and pass result. Now this returns an expectation object. In this object, we have a bunch of methods that start with to. These are called matchers. We use these to verify expectations. For example, we have to be called, to be defined, to be falsy, to be greater than, and so on. As we go through the course, we're going to get familiar with these matchers. In this lesson, we're only going to use the to be matcher. So we expect the result to be 2. This is how we structure our test. Now, we don't necessarily have to add these comments. We can use a vertical line break to separate these sections. This way, it's immediately visible that the first part is the arrange part, the second part is the act part, and so on. Now, for simple cases, we don't even have to have all these parts or all these phases. We can combine them to make our test more concise. For example, we don't need to declare these two constants because they're only used on this line. So we can replace A and B with their literal values. Now we don't need the arrange part. And similarly, we can combine these two lines into a single line. So we replace result with a call to the max function. Now our test has a single line of code. So back in the terminal, let's run npm test or npm t. All right, we have one passing test, beautiful. And look, the test name clearly identifies the scenario we are testing. Now, back in our test, if I change this value to 1, now back in the terminal, look, now we have a failing test, and the failure is happening on line 6 of this module. So the test expected 1, but it received 2. So back to our test, let's change it back to 2. All right, that was our first test case. Now, we need 2 more test cases for scenarios where the second argument is greater and also the scenario where our arguments are equal. So I'm going to duplicate these few lines. So here's what we have so far. In this test suite, we have 2 test cases. Now let's change the name of the second test. And here we say it should return the second argument if it's greater. Now let's swap the order of these arguments. Back in the terminal, now we have 2 passing tests in 1 test file. And 1 more test case. I'm going to say it should return the first argument if arguments are equal. So here we can pass 1 and 1 and expect the result to be 1. Now take a look. Now we have 3 passing tests, and all these tests were executed in 8 milliseconds. Imagine if you wanted to test this function through the UI. Perhaps we have to do a few clicks, perhaps we had to fill out a form. Obviously, we could never do this in 8 milliseconds, right? It would take several seconds. But we are not done yet. Now that we have fully covered this function with tests, let's refactor it with confidence. So we're going to replace these 3 lines with an expression like this. Return, if A is greater than B, return A, otherwise return B. Back in the terminal, look, our tests are still passing. This is the beauty of unit tests. They give us immediate feedback if we have broken something during our refactorings. However, if we go back here and let's make a deliberate mistake, let's return A in both cases. Now look, one of our tests failed. And that is this particular test should return the second argument if it's greater. So we expected to get 2, but we received 1. So let's go back and fix the error. All right, so that was our first test. Now, as we go through the course, we're going to look at more complicated and real-world examples. All right, here's your exercise. In the same module, we have a function called fizzBuzz. It's a very popular function that comes up in coding interviews. So this function receives a number. If the number is divisible by 3 and 5, it returns fizzBuzz. If it's only divisible by 3, it returns fizz. If it's only divisible by 5, it returns buzz. Otherwise, if the number is not divisible by 3 or 5, it returns that number as a string. Now, as your exercise, I want you to cover this function with tests. Now, to give you a hint, when writing tests for a function, you should cover all the execution paths. So here we have 4 execution paths. Here's the first one, second, third, and fourth. spend 5 to 10 minutes on this, and then come back see my solution. So back to our test file. Here we have a test suite for the max function. Now we need to define another suite for testing the fizzBuzz function. So we call describe and pass fizzBuzz. Now here we have a scenario where the argument is divisible by 3 and 5. So it should return fizzBuzz if argument is divisible by 3 and 5. I'm going a little bit faster because I'm assuming you have done your exercise. Then we pass an arrow function. Now, once again, here we don't need to have separate arrange, act, and assert faces. We can combine all of them into a single line because our test is very simple. So we call fizzBuzz and give it a number like 15. Then we make an assertion and check to see if the result is fizzBuzz. Now back in the terminal, beautiful, we have 4 passing tests. Now to make sure that we're testing the right thing, let's change this to fizz. Now we have 1 failing test, lovely. So let's revert it back to fizzBuzz. This is a very simple and useful technique to ensure that you're testing the right thing. Because sometimes your test might pass, but it might not be testing the right thing or even the right function. So always make a tiny change to make sure that your test and production code are in sync. Another way to go about this is by modifying the production code. So instead of changing the test code, we can go back to the production code and create a bug. So here we can add an exclamation mark. And now look, we have 1 failing test. So this verifies that our test code and production code are in sync. In other words, our test is actually testing this function. Because otherwise, let me show you an exaggerated example. Let's imagine instead of calling to be, we had a call to be defined. So we're checking that the value that is returned from this function is defined. With this test, now our test always passes even though we have a bug in our production code. If we make any changes here, our test still passes. So this shows that we are not testing the right thing. This is what we call a false positive. So our test always passes, giving us an illusion that our code works. We can also have false negatives, tests that always fail even though there's no bug in our production code. So this technique is very useful to prevent false positives and false negatives. We want to make sure that our test code and production code are in sync, or in other words, we're testing the right thing. So let me bring back the to be matcher and compare the result with fizzBuzz. Okay, now we have a failing test, lovely. So let's go back and fix the bug. Good. So we're done with the first test case. Now let's move on to the second test case. So I'm going to duplicate these few lines. This time we say that our function should return fizz if argument is only divisible by 3. So we can pass 3 or 6 or 9. It doesn't really matter. Let's compare it with fizz. We have 1 passing test. Now to make sure that we're testing the right thing, again, we can go back to our production code and make a tiny change here. There you go. Now we have a failing test. So our test and production code are in sync. Now we need 2 more test cases. So let's duplicate this test and change the name to, it should return buzz if argument is only divisible by 5. So here we pass 5 and compare the result with buzz. 1 more passing test. And the last test case. It should return argument as a string if it's not divisible by 3 or 5. Okay, so let's pass, let's say 1. And here we expect to get 1 as a string. 7 passing test. But if you pass 1 as a number, now we have a failing test, okay? So let's revert it back. Beautiful. We're done with this lesson. Next, we're going to talk about test-driven development. There are two ways to write tests: code first or test first. Code first is what we have been doing so far. We write the application code first, and then we cover it with tests. Test first is the opposite. We start with tests, and then we produce the application code. This approach is also called test-driven development, or TDD. TDD is a way of building software. It follows a simple, effective, three-step cycle. We start by writing a failing test, and then we write just enough code to make the test pass. Then, if necessary, we refactor our code while ensuring that all tests still pass, and then we repeat. Let's see this in action. So let's imagine we want to create a function for calculating the average of values in an array. So we start by writing a failing test. So back to our test file. First, we create a new test suite. Let's call this calculate average. Now here we start with a test case for an empty array. Let's say that if we pass an empty array to this function, we expect to get not a number. So it should return not a number if given an empty array. Now first we need to create this function. So back to our intro module, we define a function called calculate average that takes an array of numbers and then export it from this module. So we're not going to implement this yet. We just have the declaration of the function. Now back to our test. So we call calculate average and give it an empty array and then expect the result to be not a number. Okay, back in the terminal, look, we have a failing test because we expected not a number, but we received undefined. Because in JavaScript, all functions by default return undefined unless we explicitly return a value. So to make this test pass, we go back to our intro module and write the simplest implementation possible. So we return not a number. Now, we have one passing test. Beautiful. That was one cycle. Now we need to repeat this with other test cases. So as our second test case, we're going to call this function and give it an array with a single element. So we can change the test name to should calculate the average of an array with a single element. So we call it and give it an array with just one and expect the result to be 1. Now look, again, we have a failing test, so we have to write just enough code to make this test pass. So back to the intro module. Now we can say if numbers, the length equals 0, then we return another number. Otherwise, we return numbers of 0. Obviously, this logic is still immature, but we're going to enhance it with more test cases. So back in the terminal, now we have 9 passing tests, so we completed one more cycle. Now let's write another test case for an array with 2 elements. So back to our test file, let's duplicate this test case and say it should calculate the average of an array with 2 elements. So if we pass 1 and 2, we expect the average to be 1.5. Now look, again, one failing test. So we go back to our intro module and write a simple logic here. We can use a for loop to iterate over this array and calculate the total of all values, or we can use the reduce method. So here we call numbers.reduce and give it an arrow function. This function should have 2 parameters. The first parameter is an accumulator or a variable that contains the total value. We can call it total or sum, that's better. The second parameter holds the current value, one value at a time in this array. So we can call it current. Now in the body of this function, we simply add current to sum. So we return sum plus current. So this function is the first argument to the reduce method. Now, as the second argument, we need to provide the initial value for the sum. So we initialize it to 0. Now with this, we get the sum of all numbers in this array. And finally, we can divide sum by numbers dot length. Now back in the terminal, all our tests are passing, lovely. So let's write one more test case. This time we want to pass an array with 3 elements. So if you pass 1, 2, and 3, the average should be 2. Now look, all right, all our tests are passing. So this was TDD in action. We started by writing tests, and as a result, we produced this function. Now, the beautiful thing about TDD is that it produces production code that is 100% covered by tests. So here we don't have any execution paths that we haven't tested. The current implementation of this function is fully covered by tests. If the implementation is not complete yet, we can add other test cases to drive the development. The other great thing about TDD is that it prevents us from over-engineering because our focus is on writing the simplest logic to make the tests pass. And we can always refactor and refine our implementation. What matters is that we are not over-engineering ahead of time. So these are the benefits of TDD. But in practice, TDD can be difficult, especially for new learners. So in this course, our focus will be on the code-first approach. But as you learn unit testing, you can challenge yourself and start exploring TDD. First, it might be difficult, especially in more complex applications. But trust me, over time, with practice, it gets easier and easier. Now, I just want to clarify something here. TDD as a philosophy is great, but it doesn't mean that you should always write tests using this approach. I know that there are some folks that are fanatic about TDD and they say, you're not a developer if you don't use TDD. But again, this is one of those extremely radical viewpoints. If you don't like TDD or if you prefer to write tests after the production code, that is perfectly fine. Again, there is no one-size-fits-all in software engineering. Every project, every team is different. So always use the approach that works for you and your projects. Now, as your exercise, I want you to implement the factorial function using TDD. We have all studied factorial at school in math. Now, to refresh your memory, the factorial of a number is the product of all positive numbers from 1 to that number. Here are a few examples. So factorial of 0 is 1. Factorial of 1 is 1. Factorial of 2 is 2 times 1. Factorial of 3 is 3 times 2 times 1. So write a test case for each of these scenarios and then implement the factorial function. All right, so we start by creating a new test suite called Factorial. First, we write a test case for the factorial of 0. So should return 1 if given 0. Now, first we need to create the factorial function. So back to our intro module, we export a function called factorial that takes a number, and we leave out the implementation. Now back to our test, we call factorial and give it 0. And then we expect the result to be 1. Back in the terminal, obviously we have a failing test. So to make this test pass, we go back to our intro module and return 1. All right, our test is passing. Now the second test case. So we duplicate this and change the test name to, it should return 1 if given 1. Our tests are still passing, lovely. So let's add another test case. Should return 2 if given 2. Now back to our function. Here we need a bit of logic. We can check if n equals 0 or 1, then we return 1. Otherwise, we can do a trick. We can just return 2. We hardcode this value and our tests are still passing. So what I want to emphasize here is that we want to write just a little bit of code to make our test pass. We want to do baby steps. We don't want to have a big step where we write a lot of logic because that can lead to over-engineering. So our tests are still passing. So let's add another test case. Should return 6 if given 3. So factorial of 3 should be 6. Now, one of our tests is failing, so we go back to our factorial function, and this is where we make another step. So instead of hard coding 2 or 6, we implement the actual logic. Here we can use recursion, so we multiply n by factorial of n minus 1. All our tests are passing, lovely. Let's add one more test case. What if we pass 4? Factorial of 4 should be 24. All right, all our tests are still passing, beautiful. Now, what if we pass a negative number? Well, that's one of the areas that is debatable, but we can say that factorial of negative numbers is undefined. So we write another test case here and say it should return undefined if given a negative number. So we pass -1 and expect the result to be undefined. Now we also have a separate matcher function here that is to be undefined. We can also use this. Back to the terminal, one of our tests is failing. So back to our factorial function, let's add another if statement and say if n is less than 0, then return undefined. All our tests are passing, lovely. Now I just want to clarify something here. As part of writing tests, whether we go with the code first or the test first approach, we don't want to test against all possible numbers in the world because that is not practical. So we don't want to test a factorial function with a million different numbers. We want to have enough numbers in different ranges like 0, positive, negative. As long as we have a few different test cases for different scenarios, that is sufficient. All right, what's next? Well, if you want to learn more, I have a comprehensive JavaScript unit testing course on my website. What you have watched is the first 40 minutes, but the full course is 4 hours long and goes way beyond the basics. We'll talk about various techniques for writing effective tests that are robust, maintainable, and trustworthy. We'll talk about positive and negative testing, boundary testing, writing parameterized tests, testing asynchronous code, and using mocks and spies to isolate code during tests. We'll also have a section on improving code quality using static analysis tools. We'll talk about formatting code with Prettier, linting it with ESLint, catching type errors with TypeScript, and automating code quality checks with Husky. So by the end of the course, you will have a strong foundation in unit testing and will be ready to learn about testing front-end applications like React. The full course is packed with a ton of exercises so you can practice what you will learn. And the best part is that it comes with a certificate of completion and a 30-day money-back guarantee. So if you're not satisfied, just ask for a refund. If you're interested, use the link below this video to enroll. I hope to see you in the course. Thank you and have a great day.